This tutorial is about coding and plotting mathematical functions in MATLAB. It is related to optimization at this point, but it can be used for all sorts of exercises, as can be seen later. So suppose we have a function, one-dimensional function of one variable. So and it's a arithmetic difference of sine of its value and a square of its value. So it's a nonlinear function and we want to plot it in MATLAB. So previously you have seen that you can create an X array and then find the values of f for the different values of x and then plot it. But this lab will show you how you can use mathematical function writing capability of MATLAB, and it's typically described with a handle, which is an @ symbol. So in this line I'm coding up this function, and what I'm saying is that f is a function of x, and then after a little space, one space, I describe that function and then put a semicolon at the end or not, depending upon if you want to echo it or not. So this basically writes that function. So if we copy paste it and enter it, you will see that it has created that function in MATLAB. Now f, anytime you print f, you will see that it is saying f is a function of x, which is 2 times sine of x minus x squared over 10. And I can find the value of function f at different values of x. So the function f at 0 is 0. Similarly, function f at 3 is minus 0.6178. So this way you can define a function and get values at different values of the independent variable. Now there are also different functions, MATLAB built-in functions to plot a function. It's kind of using the function twice in a sentence, but one is a MATLAB function to do something. This is a mathematical function that has a handle given by f. So I can plot this, easy plot, it's called easy plot, and I can just put the function f, and MATLAB knows how to plot it. It identifies itself, in this case it kind of went from -6 to +6, and it found all the values of the function and it plotted for us. Now we can also tell MATLAB that we want you to plot this function from within a given range or domain, and we can add that after specifying the function. We can say I want to plot this from -10 to 10, and this way it will change the plot. And the reason I picked this function because it's actually from your book, and it has a couple of different minima there, 1, 2, 3, and if you actually plotted it around, you know it's a sine function on top of a parabola, so you will see a lot of minimas everywhere, and depending upon where you start, you will get different minima as we proceed with the optimization. So this is how you can create mathematical functions and plot them.